Hello everyone, I'm Yashaswini, fourth year EC department. So here my topic is about IoT based home automation solutions which I've done in the Emertxe internship. So next the contents will be like topic learned during the internship, general descriptions of the project, functional requirements, conclusions, project demo. So topic learned during the internship, which is like Introduction to C, data types, conditional constructs and operators and array, pointers and functions, recursion, constant qualifiers and strings, so strings and the storage classes. So they have taught about uh, introductions to embedded systems also. So the embedded means something that is attached to another thing, so it can be thought of the computer hardware system having the software embedded in it. So an embedded system can be an independent system, or it can be a part of large system and this microcontroller or microprocessor based system which is designed to perform a specific task. So which is an example like fire alarm in an embedded system, as it will sense only the smoke, the traffic lights, washing machine, dishwasher, refrigerator and features, etc. So IoT and its application. So IoT, which is a Internet of Thing, which describes a physical object or the group of such objects with sensors. So processing ability, software, and other technologies that connects and exchange the data with other devices and systems over the internet or the other communication network. The applications are home automation, wearable technology, connected health, and appliances with remote monitoring capabilities, smart traffic control, smart parking, electronic collection systems, vehicle control, safety, and road assist. So general descriptions of the project. So objective of the user, the home automation should be simulated on the Pixim Lab simulator. The Blink IoT application used to control the devices such as lights, temperature of home, inflow and outflow of the water in the water tank. So IoT based home automation solution. So here we use the mobile application, which is a Blinkit app. So then Blink cloud server, then Pixim Lab for the home automation solution. Requirements, the functional requirements. Here we have done the three under this we have done the garden light control, temperature control system, water tank inlet and outlet valve control. So garden light control, which requires a LED sensor as input, and the garden lights will be our output. So working here, we use Arduino LDR sensor and light. So read the LDR sensor value based on the reading from like in LDR. Vary the brightness of the LED, which resembles the control the garden light based on the availability of the sunlight. Temperature control system. Here we have used the Blink IoT app, Arduino board, and CLCD temperature system. So here for the temperature control systems, input as a sensor, which is we have taken LM35 temperature sensor. Output will be, it will display the temperature on the gauge widget, display temperature on the CLC. Cooler control system. So uh, input button which is a color cooler button on the Blink IoT app. So output will be, so if the button is at logic high, turn on the cooler. If the button is at the logic low, turn off the cooler. Heater control system, input widget on Blink IoT app. Output, if the button widget is at the logic high, turn on the heater. If it is low, logic low, turn off the heater. Threshold temperature control, input as LM35 temperature sensor. So if the temperature is more than 35, turn off the heater and sends the notification to Blink IoT app and display the same on the CLCD. So here working. Temperature control sensor consists of heating resistor and LM35 temperature sensor and the cooler, which resembles the temperature control system at the home. So read the temperature from the temperature sensor LM35 and display it on the CLCD. Control the temperature of the systems by turning on or off the heater and the cooler through the Blink IoT app. So water tank inlet and outlet systems. Here also we have used the Blink IoT app, Arduino Uno, CLCD. So except that water tank, we have used the temperature in the temperature control system. So here for the display the volume of the water in the tank. Input will be serial tank. Process like read the volume of the water in the tank by sending commands through serial communications. Output display the volume of the water on the gauge widget. Display the volume of the water on the CLCD. Next, the inlet valve. So input as the inlet valve button, which is a button widget on the Blink IoT app. Process will be the detects the change in the logic level. So if the button widget is logic high, turn on the inlet valve by sending the commands through serial communications. If the button widget is at the logic low, turn off the inlet valve by sending commands through the serial communications. So outlet valve controller input as an outlet valve button, which is a button widget on the Blink IoT app. So detect and it will detect the change in the logic level. Output will be like the button. If the button widget is at the logic high, turn on the outlet valve by sending commands through the serial communications. If the button widget is at the logic low, turn off the outlet valve by sending the commands through the serial communications. To control the volume of water in the tank, so input will be serial tank. Read the volume of the water in the tank by sending the commands to the serial communications. Output, if the volume of tank is less than 2000 liters, turn on the inlet valve and send the notifications to Blink mobile app and display the same on the CLCD. So walking, so read the volume of the water in the tank through serial communication and display it on the CLCD. Control the volume of the water in the tank by controlling the inlet and outlet valve by sending the commands through the serial communication. Display the volume of water in the tank on the CLCD. Blink user interface under this like Blink applications. Blink has designed for the Internet of Things, which is IoT. So it can control the hardware remotely. So it can display sensor data. It can store the data, visualize it, and do many other cool things. So create a widget on mobile Blink application. Button widgets to control heater, cooler, inlet, and outlet valve. So gauge widgets to display the temperature and volume of the water in the tank on the mobile applications. Terminal widget to display the notifications whenever threshold is crossed, like temperature is more than 35 degree, turning off the heater, water level is full, water inflow displayed. So in this table, we'll get to know the inlet control and outlet control. So here the water in the water which is in the tank, it will be showed in this table tab. So button widgets to control inlet valve, outlet valve, gauge to display volume of water in the tank, and terminal to print the notification. So button widget to control the heat, cooler, and gauge widgets to display the temperature. Threshold control. So when the heater is on, if the temperature rises above 35 degree, as I said before, the heater should be turned off automatically, and the message temperature is more than 35 degrees Celsius, turning off the heater should be displayed on the virtual timer on the CLCD. So when the water in the tank is full, turn off the inlet valve automatically and display water level is full, inflow display. This is a CLCD which acts like a dashboard, and here we'll get to know about the temperature or any notification. It will be displayed on the CLCD. So even window, so this is our output. So water inflow enabled, water level is full, water inflow displayed, and temperature is more than 35 degrees. It will all show in the event window. So conclusions. So using the Blink IoT application and PixSimLab simulator simulated home automations where LED temperature system, serial tank, resembles light, heater, cooler, and water tank in the real time. CLCD acts like a dashboard used for displaying the events. Widget from the Blink IoT apps like button widgets are used to control heater, cooler, and inlet and outlet, while gauge widgets to display the temperature and volume of the water. Here, the project demo will be started. This is the program code for our project. This is the main program. This is the LDR. This is the pins for LDR turning and off, turning on and off. This is the pins which are connected to the temperature gauge, cooler, heater, water gauge, outlet, V pin, blink terminal. This is operating the serial tank. This is for operating the temperature. Now I will compile it. Then I will export the file. Then I will go to Pixim Lab Simulator. Now I will go to simulator, Pixim Lab Simulator. I will load the file, reload the last file, then reset. Now I will open serial remote tank. In this we have using COM1, COM2 as a port. Now I will connect this port 1. This is how it will display. Here I will switch on the inlet valve. This is how the water will be filled. Water level is rising. After reaching 2000, it will switch off automatically. And we will get the notification as like water level is full, water inflow disabled. Now I will switch on the heater. This is also automatically will be switched off after reaching 35, and it will be switched off automatically after reaching 35. I will turn on the cooler. This is how the cooler will run on. Here we can see cooler is running. In this LED will be switch on if LDR is more. Here the LED will be turned on if the LDR is increased. If we decrease this, the LED will switch off. Likewise, then in the daytime it will be switched off. In the night time it will be switched on automatically by sensing the light. This is our project. Thank you.